Hello and welcome to this new course in which you will learn how to update your ESP32 board over the air. This is Ashraf from Educational Engineering team. In this course, you will learn how to do over-the-air updates for your ESP32 boards using a very easy and simple to use library. We will create a web server that permits you to upload your new firmware, your updated sketch to your board without having to make a serial or wired connection between the ESP32 board and your computer or laptop. OTA updating is a way for the ESP32 to update its firmware, and this particular update does not require a physical connection, and it can be made wirelessly and in any location, just like mobile phone updates and Windows updates. This is a very great feature to be added to your product devices or to the projects that you are working with your clients. So, what you will learn in this course? You will learn what is OTA and why you should use it. We'll talk about the libraries you need for OTA updates. And we'll take a coding example in which we write a simple code to enable web server on our ESP board, and we will add the OTA functionality. We will upload our first code over the air, and you will see that yourself inside the practical section. You will also learn how to change your previous project's code and make them OTA enabled, which means that you can enable OTA on any project you are working on or you have previously worked on. I'm sure that by the end of this course, you will enjoy every step of the way and you will end up having your ESP32 board ready to be coded and ready to be loaded with a new code over the air. Thanks for watching this introduction. See you inside. Hello and welcome to this new lesson in which we are going to talk about what is OTA. OTA, or over the air, is firmware update, which is the process of updating firmware for the ESP32 board by logging into a laptop or computer using an available Wi-Fi connection instead of using a serial cable. It uses this capability if no physical connection is available, and it has a lot of features. Now, imagine that you have your project in a place that you cannot access, or if you have your ESP32 project far away from you and you have to travel to update the code, or if you have a client or a distant client like in another country and it requires or he requires a continuous code update. OTA, or over-the-air update, is the solution. Plus, if you are sharing a device or a product and you want to keep sending updates to your customers, this is the feature to look for. OTA update helps you update your code wirelessly over the internet or over a local network connection without a physical cable, without the serial USB cable that you usually use to upload your code to your ESP boards. This feature allows you to enable updates over the air. That's why it's called OTA update. It's like updating mobile phone firmware by companies sending the update over Wi-Fi connection and users receiving this update, and the phone is up and running. Same thing will happen with our ESP32 board, and in this course you will learn how to do that. You will learn how to turn any previous project or any new project that you do using ESP32 to an OTA enabled project, which means that you will be able to update your project code over the air, and you'll be able to release new versions of your code over the air without having to be physically available around your board with wired connection. OTA is 100% wireless update of your ESP32 board. Hello and welcome to this new lesson in which we are going to talk about different libraries that you can use with over-the-air programming. Now, there are a bunch of options when it comes to programming your ESP board using OTA method. For example, in the Arduino IDE, you can find in the examples that are provided by Arduino and the different libraries that are there by default, you can find that we have basic. You can find quite few libraries in Arduino libraries section. And you can test them out, but in this lesson, we will show you the one that worked for us. We are going to use a library called Async Elegant OTA library. It's one of the most used and most common libraries with the OTA feature, and it's just perfect with what we are looking for here. Now, what is great about this library is that it provides a user interface out of the box. As you can see in this preview, we have this user interface. You don't have to do anything, any coding, any JSON or HTML coding. You will just download and install the library and it will be ready for you to use. It provides a beautiful interface to upload over-the-air .bin updates to your ESP modules with precise status and progress display over the UI that you will see on your web browser. Now, this library also shows the current upload progress of your OTA, and once finished, it will display the status of your OTA. Now, this version of the library uses Async Web Server, which is a web server that we usually use in our ESP32 projects. So this is another advantage. Now, this is the preview, and here we have the installation, let's say instructions, and it also comes with a documentation on what you need to use or to do to make your project, let's say, ready to be OTA updated. Now, we will use this library and I will show you how you can easily install it into your Arduino IDE. Now, this is Arduino IDE. The first thing that you need to do is to go to the Libraries Manager. So go to the Tools menu, Manage Libraries. In here, you need to install few libraries, not just the Elegant OTA. So let's start by searching for the Async Elegant OTA. As you can see, this is the library. Performs OTAs for ESP8266 and ESP32 asynchronously, a user interface library which provides interactive elements for your over-the-air updates on both of these boards. So click install. Now after installing the first library, which is the Async Elegant OTA, we also need the Async TCP library, and we will need the ESP Async Web Server. Now, if you went to the Arduino IDE, you can go to the Tools and Manage Libraries and look for the Async TCP library. You will find quite a lot of libraries, Async TCP. Now, any of these would work for us, but you need to know what you are installing by clicking More Info. And you can also search for ESP Async. Now, again, you need to make sure that it supports the ESP32. So as you can see, here we have the Async Elegant OTA library that we installed. And here we have the Async HTTP request. Now, we need to write the word web because we need a web server library, and here it is. Now this might work for us, Async Web Server, but to make sure that we are getting the right libraries, we will use the MinoDev version of ESP Async Web Server, and we will use the async TCP library from the same developer. So you can go to GitHub and see MinoDev, who's a Bulgaria developer who made these two libraries. We use them and they work for us, so we will keep using them. Now we will use the let's say old method to install the libraries, not the library manager that you see here. The library manager is connected to Arduino Cloud, and what we need to do is to install these libraries manually. So to do this, as you can see, we have a lot of options on these menus. We need to include a library. Go to Sketch, include library, and from there, add .zip library. Click on it, and from there, you can simply go again, add .zip library. Now from there, you can simply go and visit the place where you have the libraries from the recent items menu, let's say, and from here, we will go to the libraries. Then we have these async TCP master library and ESP async web server master. So double click the first one. Now library added to your libraries. Go again, Sketch, include library, add .zip library, and again go to the same location, libraries, double click the second library, and as you can see, library added to your libraries. So now we have the three libraries, the async elegant OTA library, the async TCP library, and the ESP async web server libraries. Now the async TCP library, this is a fully asynchronous TCP library aimed to enable trouble-free multi-connection network environment for ESP32 MCU, and this ESP async web server is basically a library that will help you create a web server on your ESP board, and it has a lot of documentation if you want to go through. Now, after installing these libraries, you are ready to go. So the next step will be encode our first example and add the necessary lines to make it OTA enabled, let's say. Thanks for watching this lesson. If you have any questions, please ask in the Q&A board. I'll be more than happy to help. This is Ashraf from Educational Engineering Team. And welcome to this new lesson in which we are going to start with our first example. It will be a basic example in which we are going to create a web server using our board, the ESP32, and we will use the IP address to access our ESP32. Then we will see how we can add the OTA to our code so that we can easily update the software on the go without connecting wires wirelessly or over the air. Now, the first thing is including the libraries. So let's include our first and most important library, which is the async elegant OTA library. Now the second library will be the async TCP, the one that we installed manually. So write async tcp.h. Now the async TCP is the library that we installed manually, and as you can see, it is here. So if you clicked here, it will be added, but we just wrote it, so we'll delete this. I'm just showing you that it is installed. Now we also need to include the ESP async web server library, which is the third library that we manually installed, and you can also see it here. If you went down, ESP async web server library, and you can also click here, it will add all of these. But we don't need all of them, we just need the ESP async web server, which is this one. Now, once you are done, You will also need the Wi-Fi library because we need to enable Wi-Fi on our ESP board. So simply write Wi-Fi.h. This is the header file of the library. Now, these are the 4 libraries that we will need. Let's also create the 2 main variables for our Wi-Fi connection. Constant character. So we'll create a pointer, call it SSID. And in here, you need to add your Wi-Fi network SSID. And we also need to create another pointer for the password. And when I say pointer, this asterisk sign means that here we are defining a pointer. The type of this pointer is character, and the name is SSID. Now, pointers is explained in our C programming course. Now, after doing this, we need to start the web server. So we'll create an async web server object on a specific port, and for this example, we will use port 80, which is the default port. So async server, and here you need to add 80. Now, I usually like to verify my code before moving forward and save it so that your work won't be lost. So let's create a new folder, call it codes, and let's call it simple code ESP32. Now, verifying the code will help you know the errors as they happen. Now we have few lines of code, and if we have an error, we can easily fix it. Now go to the tools. Here we have an error because we have the wrong board selected, Arduino Mega. So we need to go back, change the board to ESP32. And the one that we will use is DoIt ESP32 Dev Kit version. So again, verify. Okay, now done compiling without any errors. Let's initialize the serial monitor. So write serial begin and 115,200, which is the baud rate for this serial. After that, we need to initialize the Wi-Fi. And the Wi-Fi code is pretty straightforward. We usually write it or copy it from anywhere. We will start by enabling the Wi-Fi mode. And we will use Wi-Fi STA. After that, we will begin the Wi-Fi connection with the given SSID and password. So SSID, password. Then we will start the serial monitor by printing an empty string. Or you can say Wi-Fi connection attempt. Then we will write the famous while loop that will keep printing dots if you are not connecting to the Wi-Fi network. So here we have our while loop. So if not connected, we need to wait for like 400 milliseconds, and then we will print serial.print. And in here, we need to write a dot inside the while loop that will make sure if Wi-Fi is connected. If Wi-Fi is not connected, it will keep printing dots and trying to connect. Now write Wi-Fi status, which is a function that will return the status of our Wi-Fi network, and write connected. And by the way, this is called a C macro. So this is usually a number written in the Wi-Fi library. So CONNECTED. So if not connected, keep printing dots. Wait, keep printing dots, and so on. Now, if it is connected, we need to print few lines. So serial.print ln. We will start with an empty line, and I will print few things. Connected to Wi-Fi network with name, and then we will print the SSID because it has the Wi-Fi network name using the print without printing a new line because we need it to be printed on the same line. Now you can even get the IP address, which is something we want because this IP address will be used to access our ESP board. So we will write print IP address for Wi-Fi, for ESP, sorry, 32. Then we will use the local IP function, print new line, Wi-Fi dot local IP. This function will return the local IP for our ESP board. Now, after doing all of this, we are connected to the internet, which is the first step in our program. The step after this is to handle the client requests. So we are going to write 2 or 3 lines of codes to send any text like, hi, hello, this is Ashraf, or this is education engineering team, and your ESP32 board is online. Now, this text will be printed whenever you access the root IP address. And to do this, we can simply send this line of code. Write server. And when we say server, we mean the server that we initiated here. So here we are calling the object, which is server.on. Then you need to add 2 parentheses and a semicolon. Now between the 2 parentheses, you have to add 2 double quotation or double quotes, then add a semicolon. Now we added backslash. After the semicolon, we need to send the request, which is HTTP GET. Then add another semicolon, add 2 brackets, and add 2 parentheses. Now between the 2 parentheses, we need to write async web server request asterisk request. So this is basically a pointer. Now after that, we need to send the request itself between 2 curly braces. So write request, then write send. After that, you need to add 2 parentheses and add a number, then the type of thing you want to display. It will be text plain, and we need to add another semicolon, then add the text that you want it to display. Let's say hello, this is Ashraf, educational engineering. That's it. Now let's do this on 2 lines of code. Now we have, okay, we can split it here. That's it. This will be our code. Now this is the server.on. After that, we added 2 quotations and a backslash, semicolon, the request type HTTP GET, another semicolon, 2 brackets, and 2 parentheses. Between them, we created a pointer called it request from the async web server request type, which is a type from our library. Then we added 2 curly braces. We sent the request, and the type of data that will be displayed is text. And this is the text that we will display on our web page. Now, once done, we have the request ready. The last step inside the setup is starting the elegant OTA server. So make sure you are here, write async elegant OTA dot begin, and we'll pass the server address. So add and server. This will pass the address of our server memory to the begin function of the async elegant OTA, which is the over the air update library. Then we will start the server itself, write server begin, and we will print on the serial monitor anything to indicate that the server started. Elegant OTA initiated, and we need another line. Here we need to write HTTP server has started successfully. Now once you are done, this is the end of our code. As you can see, we have our elegant server started, we have our web server started, and we have the text to be displayed on the root IP address, and this code is ready to be shipped to our board or ESP32 board. Now let's verify the code again to see if we have any errors to fix them before uploading the code. Now in the next lesson, we will upload the code and we will test this practically and see how we can send our bin file. Now, as you can see, we have an error here. It's saying that it expected us to write a semicolon before the curly brace here. So let's see. Okay, here, that's right. Here we have missed a semicolon at the end of this request. So make sure that you have the closing parentheses, semicolon, curly brace, closing parentheses, and another semicolon. Click verify again. This structure is something you can copy, you don't have to memorize. And we will provide the code for you to check out. But we usually like our students to write their own codes so that they will learn along the way. As you can see, done compiling. Now what is left is uploading the code to our ESP32 board. This will be done on the next lesson. So now let's do a quick overview of this code. First, we imported the async TCP, the web server library, and the elegant OTA library, which is the main library for our course. We also imported the Wi-Fi library because we need to enable Wi-Fi connection. We created 2 pointers, SSID and password for our Wi-Fi network name and password. We created an object from the async web server, called it server, and the port will be 80. Inside the voice setup, we started the serial communication. We choose the Wi-Fi mode to be Wi-Fi STA. We began the Wi-Fi connection with the Wi-Fi network name and password. Then we printed Wi-Fi connection attempt. We use the while loop to check if Wi-Fi is connected using the Wi-Fi status function, and if it is not connected, it will keep printing dots and waiting for 400 milliseconds. Then, once connected, it will print connected to Wi-Fi network with the name printed of our Wi-Fi network. Then it will print the IP address for our ESP32 board. After that, we send a request, a GET request to our web server to display this text on the root web page. Then we started the OTA with this server address, and we started the server itself. Then we printed these 2 lines, elegant OTA initialized, HTTP server has started successfully. Now we can also print another line. To access OTA update, type And after that, we will use the local IP address in here, and we will print this sign with the backslash sign, and the last step will be printing the word update. So this will show the user what he needs to enter to access the OTA update page. Once done, simply click verify again. And again, in the next lesson, I'll show you how to upload this code to your ESP board and how you can easily update the code using OTA feature without any cables. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which we are going to upload the code to our board. Now, the first step is connecting your ESP32 board. Go to the device manager to make sure it is connected. Now go to the COM ports section and you will see COM4 for the Silicon Labs CP210X USB to UART bridge. So go here, select tools and make sure that port for COM4 is selected, exactly like in the device manager. Now once you are very sure that you have the right board, do it ESP32 DivGit version 1 and the right COM port. The last step is clicking the upload button. Now you need to make sure that you have edited the SSID and the Wi-Fi password information to match your local or your Wi-Fi network. Once you are done, verify and upload the code and you will see this message connecting. Now it's trying to connect to the ESP board. Once connected, it will start uploading the code. Now we have an error timed out. So let's try again. Now I have switched the USB cable. The previous cable had a problem. Now we are uploading the sketch again. Now as you can see, it's uploading the code without any problems. So we just need to wait and see the serial monitor once the upload is done. Now, as you can see, it's doing a hard reset. Now it's trying to connect to the Wi-Fi network. These dots in our code means that there is an attempt to connect to the Wi-Fi network, as you can see here. We might need to do another reset. So simply hit the reset button. Now as you can see, Wi-Fi connection attempt. Great, now it is connected. Here we have Wi-Fi connection attempt, which is the line that we wrote. These are the dots while trying to connect. Once connected, it will write connected to Wi-Fi network with the name Ashraf. Now the IP address for ESP32 is 192.168.0.100. Now elegant OTA initialized. The server has started successfully. To access OTA update, you need to type this 192.168.0.100/update. So let's copy this and let's go to our browser, and here we will paste this 192.168.0.100. Now before going to the update, we need to go to the root. This is the line that we wrote. Hello, this is Ashraf Educational Engineering. Now if we pasted the original link 192.168.0.100, which is the ESP32 address, then \update, press enter, and you will see the elegant OTA update interface. Now all what you need to do is select choose file, then update your ESP32 board. Now this is to update the firmware, this is to update the file system over the air without connecting the COM port. And we will do this in the next lesson. Now for this lesson, all what I need you to do is to make sure that you have the board connected and the code uploaded, and you can see this user interface. Then you can move on to the next lesson. Thanks for watching this lesson. This is Ashraf from Educational Engineering Team. Hello and welcome to this new lesson in which you are going to upload new firmware OTA or over the air to our ESP32 boards. So we will upload the same code, but we will change this sentence. So let's save it in a new project, save as, and let's call it OTA underscore symbol code ESP32. Now save your code and make sure that any code that you are uploading has the async elegant OTA lines, so that when you want to make a future update, you can have access to the update section of the web server. So it depends on any code you are trying to upload. You have to make few edits. You have to add these two lines. You have to add the lines relevant to the elegant server, like this line, and add these three libraries. Now adding these will make sure that if you want to send a new update, it will be something you can do because you already have the elegant server enabled inside your new project or new code. So let's say that this is a new code and we have added the elegant OTA begin, so that whenever we have a future update, we can also send it OTA. Now let's update this line. Let's make it this code update was sent over the air OTA. Now let's compile it. Now the first thing that I will show you is that my ESP board is not connected. So go to the tools, and here we have it connected at COM4. Now I will disconnect it and connect it to a power supply instead of connecting it to my computer. So now if we went to the device manager, as you can see here, in the COM ports we don't have an ESP board. Now done compiling. Every file or every project that we need to upload OTA or over the air should be in .bin format. Now to get your .bin format for a project that you are working on using the Arduino IDE, make sure to open your sketch, then go to sketch and select export compiled binary. Once you click here, it will start compiling the sketch and will create a .bin file for you inside your sketch folder. That's the bin or .bin file that you should upload using the elegant OTA web page if you want to update the firmware on your ESP32, or if you want to send a code update to your ESP32. Now to get your binary file, you can click show sketch folder, go to sketch. Once done compiling, click show sketch folder. Now as you can see here, we have the sketch folder and we have the .bin file that we need to upload. This is our sketch and this is the .bin file. Now we have our ESP connected to a power supply, so we need to try to access the IP address. Now as you can see, when you write 192.168.0.100, which is the IP address for our ESP board, you will get the default message from our previous code. So let's refresh the page to make sure that it works. As you can see, we are still getting the same code. Now to update the firmware, you need to write /update and you will get this page. Now simply copy this directory, go to choose file, again the IP address /update, choose file, and in here you need to paste your folder, and here we have the .bin file that we created. And again, we created this file by going to our sketch and export compiled binary. Bin stands for binary. Now double click on it, and as you can see, it's already uploaded to our ESP32 board. Now 100% means that the code is uploaded and ready for us to see. Now OTA success, the check mark means that there were no errors, and you can select the back button. Now you need to wait few seconds, then you need to visit the IP address. As you can see, once we visited the IP address, we have the new code uploaded and running. This code update was sent over the air OTA. And to make sure that this is indeed sent over the air, you can always go and check the port. We don't have COM4, and in the device manager we don't have COM4 as well. So we don't have any port connected, and we just sent the code over the air. Now let's do it again by updating this code. Let's write OTA version 2.0 update wirelessly. So let's verify the code. Now after verifying, we need to create a new binary file with the method that we already mentioned. Now go to Sketch, export compiled binary. Done compiling. Now go to Tools, Sketch, Show Sketch folder, and here we have the updated OTA binary. Now again, go to your web browser. Now when you refresh the page, you will see that we have this code. Write /update, click choose file, and select the binary file. Wait until you see the successful mark. Now this code is being sent over the internet or over our network without any wired connections. Success. Now back. You can visit the IP address, and as you can see, OTA version 2 updated wirelessly. That's it. Now, one last thing that we need to mention again is that when you have a code and you want to update it or to send it over the air, you need to make sure that you are adding these lines and this line, and scroll down. Also add these lines to make sure that in any future update, and if you want to send it over the air, your code will be enabled and ready to receive OTA updates. If you forgot to add these lines and you updated the code, you won't have access to the async elegant OTA update feature. Now, if I commented these lines here, and okay, here, we can leave these. If we commented this line as well, we can leave this one. If we commented the libraries and left just the web server library, and if we uploaded the code, export compiled binary. Now this code won't have the OTA feature because we removed these two lines and we remove the async line. Okay, we removed the server feature, which is feature that we should have kept because it's an ESP server or web server. Now this is the problem. Now go export compiled binary again. Export compiled binary. Okay, done compiling. Now the previous code has the OTA feature. So we can click choose file update. Now the new code that you are uploading does not have the OTA update feature, the elegant OTA library. So it will successfully be uploaded to our board, but it will not support the OTA update. So when we click go back, you will see that we have the new code, but when we select update, as you can see, this page is not working. We don't have the OTA feature. It's just because we forgot to add this line and these 2 lines for the libraries. So by enabling these 3 lines in our code, it will be OTA enabled. It's as simple as that. Thanks for watching this lesson. Now if you have any questions, I'll be more than happy to help. This is Ashraf from Educational Engineering Team.